Hello everyone, JCE Connect. I welcome you all for this particular lecture. So again, I'll be continuing problems on open channel flow, that too on specific energy. So here the problem given as in a flow through a rectangular open channel for a certain discharge, the Froude numbers corresponding to the two alternate depths are Froude number 1 and Froude number 2 show that Froude number 2 divided by Froude number at 1 whole raised to 2 by 3 is equal to 2 plus Froude number 2 square divided by 2 plus Froude number 1 square. So this is the question asked here. So in a flow through a rectangular channel, this is the rectangular channel. The question here asked at a certain discharge, the Froude numbers corresponding to two alternate depths means uh, the flow is or the discharge is taking place in two depths, two different depths, same discharge, but it is being passing in two different depths. The discharge is same, passing in two different depths. One depth lying in a, suppose if you are taking this as a critical depth YC, the depth which is below the YC is called as a supercritical flow, and the depth above the YC is called as a subcritical flow. So you will be having a two depths, one in a region of supercritical, one in the region of subcritical, and the same discharge is been passing. The discharge Q is same, which is passing in two alternate depths. So having those two alternate depths, so the Froude number at 2 divided by Froude number at 1 raised to 2 by 3 is equal to 2 plus Fr2 whole square divided by 2 plus Fr1 whole square. We need to prove this one. So let y1 and y2 be the two alternate depths. Let us take one depth here. Let us take this as a y2, and one more depth you take below yc, that is y1. So let us take y1 and y2 be the two alternate depths. Let Q be the discharge through the channel. Then we have a continuity equation, this one, Q equal to A into V. Then the A can be written as, since it is a rectangular channel, we can write B into Y. This is the formula. But this discharge we are passing in two alternate depths. So we can say, suppose this is a rectangular channel at section 1. This is 1, 1. This is 2, 2. So we may say the depth here is a y1 and the depth here is a y1 and depth here is y2, and the same discharge is passing here and here. Whatever the discharge giving here, the same is passing here also. The discharge is same but passing in two alternate depths. So we can write q1 equal to b into y1 v1. The width of the channel is same but the depth is varying. Q1 equal to b into y1 v1. As the depth varies, the discharge velocity also varies, because the velocity is inversely proportional to depth of flow. Velocity is inversely proportional to the depth of flow. As the depth varies, the velocity also varies. So we can write q1 equal to b into y1 v1. Then at section 2, q2 equal to b into y2 v2. Then since the discharge is same, one can write by continuity equation q1 equal to q2. It is q1 equal to q2. So by1 v1 is equal to by2 v2. Then where y1 and y2 be the velocities corresponding to the depths y1 and y2. Also one can write that specific energy can be expressed in terms of alternate depths. The specific energy whatever we're having at section 1 and section 2, here the specific energy is E1 and here the specific energy is E2. We know the specific energy formula, that is at section 1 one can write the specific energy as y1 plus v1 square by 2g is equal to y2 plus v2 square by 2g. That is energy at 1 is equal to energy at 2. Energy at 1 is equal to energy at 2. But energy at 1 can be written y1 plus v1 square by 2g, and y at 2 will be y2 plus v2 square by 2g. Again take y1 common, then we get 1 plus v1 square by 2g y1. Here take y2 out, 1 plus v2 square by 2g y2. I hope understood till here. Then the next, just to write the equation y1 plus, here I write as a Froude number, because we know that, because Froude number formula is what? V divided by root of g y. So here what we are having, v1 square by 2gy1. So one can write, this will becomes, if we square on both sides, we get Froude number square is equal to v square divided by gy. We get v square divided by gy. We get, substitute here this v square here, v1 square by 2gy1, v1 square by 2gy1, and in place of v2 square by 2gy2, so we can substitute, that is Froude number 1 at section 1 square divided by 2 y2 into bracket 1 plus Froude number 2 at section section 2 whole square divided by 2. Again rearrange the term, y1 by y2 is becomes 1 plus fr2 whole square by 2 divided by 1 plus fr1 whole square by 2 is equal to 2 plus, then you solve this one, you will get 2 plus Froude number at 2 whole square divided by 2 plus Froude number 1 at, that is a Froude number at section 1 whole square. Let us call this equation as a 1. This one, call this as a equation number 1. Then we also know that Froude number can be written as, Froude number is equal to v divided by root of gy. This we know the formula. Then we know q equal to a into v. Substitute the value of v here, that is v becomes q by a. Substitute here, you will be getting, then again q divided by b into y. Substitute here, you will get q divided by by root of gy. Then square on both sides. When you square on both sides, you will get Froude number square, fr square is equal to q square divided by b square gy cube. So in terms of alternate depths, if we want to write in terms of alternate depth, that is y1 and y2 are the two alternate depths. So Froude fr1's whole square divided by q square divided by q square is a constant, b is also constant, gy2 cube. So this equation we have obtained. So if we want this same in alternate depth, in terms of alternate depths, we get this one, then Froude number 2 whole square divided by q square divided by b square gy2 cube, this we get. Then from the above two expressions, one can write fr2 whole square divided by fr1 whole square is equal to y1 cube divided by y2 cube. Then q square get cancels, b square also get cancels, g also get cancels, you will get this equation. Then y1 by y2 can be written as just y1 by y2. If you want to write, when this cubic term comes this side, it becomes fr2 divided by fr1 raised to 2 by 3. This equation we get. Then compare equation 1 and 2. Compare these two equations. This equation 1 and equation 2. Compare this one. So if we compare the equation, we get Froude number 2. When you compare this equation, we get Froude fr2 divided by fr1 whole raised to 2 by 3 is equal to 2 plus fr2 square divided by fr1. This is the derivation. So this derivation is very important for the examination point of view. Please practice this derivation. Many times this question has been asked in exams. So this one, I'll repeat these questions once again. In a flow through a rectangular open channel, for a certain discharge, the Froude number corresponding to the two alternate depths are Froude number 1 and Froude number 2. Show that fr2 divided by fr1 whole raised to 2 by 3 is equal to 2 plus fr2 square divided by 2 plus fr1 square. Okay, so this is the problem. This is very very important for the examination point of view, so please practice this derivation. Thank you.